Okay, good evening, dear students. In yesterday's class, we discussed about the problematic, the hypothesis, that is T test and Q test. T test introduction is completed and formula T is equals to x1 bar and x2 bar divided by x here. T test or it is a student test. T test, the formula is T is equals to mode of x1 bar x1 bar minus x2 bar divided by x square root of n1 n2 divided by n1 plus this is a formula for finding the t test value and other critical values, that is the known value of the sample. Here, one problem. The two means of significance differentiate the 95% probability of the calculate t value. Here, the AR formation values taken in two methods. One is a x1 bar and another is a x2 bar, and fourth is x. And here example, this problem on this formula. A sample of soda ash, a sample of soda ash sodium carbonate, and is analyzed by two different and is analyzed by two different methods. Analyzed by two different methods. Giving the following results. Giving the following results. For the percentage of sodium carbonate. This is the problem. In method 1, the x1 bar is equals to 42.34, 42.3, and x1 is equals to 0.1, and n1 is equals to 5. Here in method 2, x2 bar is equals to 42.4, and s1 is equals to s2 is equals to 0.12, and n2 is equals to This is a given data or given values here. A sample of soda ash, sodium carbonate. Is taken up. The sample is sodium carbonate or soda ash. Is analyzed by two different methods. You taken a soda ash sample and it done analysis by two methods giving the following results. These are the following results for the percentage of sodium carbonate. You find at 90% of the sodium carbonate. How much percent is here? You calculate for the 90% of sodium carbonate. Take up this given values, this given data values and calculate the t-test or apply the t-test or calculate t-value. You know the formula is t is equals to solution t is equals to x1 bar minus x2 bar divided by s into n1 n2 divided by n1 plus n. This is a formula. Here the x1 bar is how much it is? The x1 bar is 42.34 and x2 is 42.44 and here s1 value is 0.10 and S2 value is 0.12. You do one time this, you take S value and one time another S value or you take a mean of S values. This is a, you take first one the S values and here S2 value. First one and in N1 and N2 value N1 is equals to 5 and N2 is a 4 divided by N1 plus N2. Here, you substitute in this formula. The value is substituted in this formula. X1 bar, how much is? X1 is 40.34 minus X2 bar 42.4 divided by S1 is 0.10. Here multiplied by is multiplied by N1 is 5, N2 is 4. 5 into 4 is 5 4 10. Sorry, 20. Divided by this. N1 plus N2, 5 plus 4, 9. This is the value. And finally, it gets the value is 1.41. T is equals to 1.41. This is the T value, the T test value. You applied your obtained value. You obtained observed value here 42.34 and x square is the 42.44 and your T test value is T is equals to 1.49. Afterwards, the simplification, after simplification, you get this value that is T is equals to 1.49. This is a t-test. You have to take another example and do the same procedure. F test. Next one, F test. F test, introduction and form. Here, F test, introduction and formula. Some points on introduction and formula. Here, the F test is named in honor of the great statistician R.A. Fisher. The scientist name, he find out he discovered the F test method. The F test method. The F test is named. The F test is named. The F test is named in the honor of the great statistician R.A. Fisher. R.A. Fisher. This is the first one. Given a F test method. And here to find out whether the two independent estimations of population variance differ significantly. Here you get some different values in population and it define it differ from significant or not. Here it differ takes place here, it is a significant or not. This is the second point. To find out whether the two independent estimates estimates of population variance differs significantly. Variance differs significantly, or to find out whether two samples may be regarded as norm from the normal population having same variance. You know what is meant by variance? Variance is the square of the standard deviation. This is the square of the standard deviation. And here the form to find out whether the two independent estimates, here it is not a dependent, it is independent estimates of populations, and here the variances differ in a significant way. Or to find out whether the two samples, you take the independent or you take the samples take population or in a sample. The two samples may be regarded as drawn from the normal populations having the same variance. Tell about this one, I will tell about this one. The normal populations having the same variance or it differ, the variances differ significantly. I write another point. Next one. To carry out the test of significant to carry out the test of significant the test of significant we have to calculate the ratio of F to calculate the ratio of F. Here, in two different points, the finding the samples, it is regarded as the normal population, and according to this, so it is carried out the test of significant to calculate the ratio of F. And here, the formula for this F test is F is equals to sigma 1 square divided by sigma 2 square. In sample, we have write the S1 square divided by S2 square. S1 square divided by S2 square. Here, the sigma 1 value is in numerator value is always greater and this always is smaller. This is also always greater and this is also always smaller. Here, the sigma 1 square greater than sigma 2 square. Here also the S1 square is greater than S2 square. And here the variance is square of standard deviation. Variance is square of standard deviation. Square of standard deviation. Standard deviation. Here, variance, that is sigma square is equals to summation of x minus square divided by n. I will take x and m and m and you take this one or you take x and mu whole square divided by n. In sample, this is changes x and x bar in sample. Therefore, s square is equals to summation of x minus x bar square divided by n minus. This is the sample. This formula for standard deviation in variance. That is a square root. That is the square is equals to summation of x minus x bar whole square divided by n minus 1. Then we simplify way f can be written as the larger estimate of variance divided by smaller estimate of variance. After this modification, if written as the f is equals to larger estimate variance divided by smaller estimate variance. In simplified way, F can be written as F can be written as F is equals to larger variance or larger estimate of variance, larger estimate of variance and divided by smaller estimate of variance. Smaller estimate of variance. See, the F test is defined as the ratio of the larger estimate of variance to the smaller estimate of variance. And degree of freedom. Next, degree of freedom. You consider here the degree of freedom. Therefore, mu1 is the numerator, and mu2 is the denominator. Here the numerator is n1 minus 1, and here the denominator is also in here n2 minus 1. This is n1 minus 1 numerator, in denominator the n2 minus 1. This is a larger variance, and this one is smaller variance. This is a larger variance and smaller variance. And here, for the calculate the F value will be compared with tabulated F value. You have some values I given in Q test values, some critical values. In this also, some critical values are calculated F value will be compared with the tabulated value. F value of mu1 is and mu2 at 1% or 5% level of a significant level. We will calculate this or apply the F test on the F test value. We will apply F test to find out F test F value or calculated F value. Here the calculated F value is less than tabulated value. I write one note here. The calculated F value less than tabulated F value. Tabulated F value. Null hypothesis accepted. And no significant difference. I know significant difference. I know significant difference. Okay, sorry. Here the calculated F value is less than tabulated F value, and here the H not is a null hypothesis accepted. I know significant difference. I know significant difference. I know significant difference between two variables. That is S square. In this F test method, the calculated F value is less than tabulated F value, and here the null hypothesis accepted and no significant difference between two variables. That is the two variances. This is a S square. It is denoted as in standard deviation. The standard deviation, square of the standard deviation is known as a variance. And the calculated F value, here the calculated F value is less than tabulated F value, and calculated F value is greater than tabulated value. See, the calculated value F value when it greater than tabulated F value, and null hypothesis resulted, and significant difference between two variables, and significant difference between two variables. That is S square. Significant difference between two variables. That is S square. Here, when calculated F value is less than tabulated value, this F value is less than this tabulated value, and the null hypothesis is accepted. No significant difference between two variables. Here, in calculated F value, F value is greater than tabulated F value. The calculated F value is greater than this tabulated F value. The null hypothesis here H4 is rejected, and the significant difference between two variants, that is S square. And hence the conclusion here, hence F test is based on the ratio of two variants. Here I'll write another point. Hence F test is based on the ratio of two variables. It is also known as this F test. It is also known as the variance ratio test. It's also known as it's also known as variance ratio test. Variance variance ratio test. This is a fourth point. Here the variance ratio means the S1 and S2. S1 divided by S2. You know that is the F test value. Sorry, F test formula. F is equals to S1 square divided by S2 square. Okay, take one problem on this F test value or F test method outline F test method. Problem here in a sample of 9 observations in a sample of 9 observations in a sample of 9 observations, the sum of squared deviation the sum of squared deviation sum of squared deviation of items from the mean was 64 point sorry the mean was 64 in another sample in another sample of 11 observations 11 observations 11 observations the value was 11 observations the value was found to be 88. Test whether the difference is significant at 5% level. At 5% level. Here, in a sample of 9 observations are given here. The 9 observations, sum of square deviation of items from the mean was 64. And n is here the mean was 64. In another sample of 11 observation, the value was found to be 88. The test whether the difference is significant at 5% level. Here the given data, right here, solution, given data, Here given data n is equals to 9. First one, here 9 observations. The n is equals to 9. And another n is equals to 11. And another here the 11 observations. Second, another is here the 11 observations. And summation of x minus x bar square, x minus x bar square is equals to 64. This one is equals to 64. And another x minus x bar, summation of x minus x bar square is equals to another this one 88. This one 88. And here let's take the hypothesis. This is a sum of the square deviation. These are the sum of the square deviation. Sum is this is sum of the square deviation, that is the summation of x minus bar whole square is equals to 88 and x minus x bar whole square is equals to 64. And then afterwards, let's take the hypothesis that variance of the two samples, are not significant. Here the null hypothesis and another the alternative null hypothesis. Null hypothesis and alternative hypothesis. Therefore, this one is equals to sigma 1 square is equals to sigma 2 square. And here the alternative sigma 1 square is greater than sigma 2 square. This is a sigma 1 null hypothesis. Sigma 1 is equals to sigma 2 square, and here the alternative hypothesis, the sigma 1 square is greater than sigma 2 square. And here it can write the f is equals to, you know the formula, f is equals to s1 square divided by s2 square. S1 square divided by s2 square. I can write here the s1 square is greater than s2 square. Okay. Apply the or add this value in the formula of f test. Here you know the f test formula, that is s square. See here, first to apply these values, the s square is equals to summation of x minus x bar whole square is equals to, see, x minus x bar whole square divided by n minus 1. Here the n minus 1 means here this is a n1 and this is n2. You take n1 and n2 here. The n1 minus 1. n1 minus 1 here. This is equals to x minus x bar whole square. This is a 64. 64 divided by, that is here the n1 is 9. 9 minus 1, therefore is equals to 64 divided by 8. Here this is equals to 8. This is equals to 8. Next, this is a s2 square. And next s1 r cube. Not afterwards you decide the s value, it is a greater or lesser. Okay. S is equals to summation of x minus x bar whole square divided by n2 minus 1. Therefore, is equals to x minus x bar whole square divided by n2 minus 1. Therefore, is equals to 88 divided by 11 minus 1. Therefore, is equals to 88 divided by 10. Therefore, is equals to 8.8. 8.8. You know the F test formula is the numerator value is greater and denominator value is smaller variance. You take this is a 8, this is a 8.8. You take this is a higher value and this is a lower value. You add this is you take this is a S1 and this is S2. Next you apply F formula, that is F test is equal to S1 square divided by S2 square. Therefore, F is equals to S1 means 8.8 divided by S2 means 8. Therefore, it gets F is equals to 1.1. And this is a calculated value. This one is a calculated value. This is a calculated value, and then the degree of freedom. Then degree of freedom, you calculate degree of freedom. Degree of freedom, this is the mu1 is equals to n1 minus 1 and mu2 is equals to n2 minus 1. You know n1 is the here the 9 minus 1 and n2 is the 11 minus 1. Therefore is equals to 9 minus 1. Here 9 minus 1 is equals to 8 and 11 minus 1 is equals to 10. 9 minus 1 is equals to 8 and 11 minus 1 is equals to 10. Sorry, here you taken this is the S1 and here you take this is a higher value is 1, lower value is 2. Okay, this according to this, and here the n1 minus 1 is equals to 9 minus 1, and therefore mu1 is equals to n2 minus 1 is equals to 11 minus 1, and 10 and 11. And here the F value is 3.35. The F value, that is critical value, that is 3.35 for F005%. F 0.0, that is a 5%, is equals to 3.35 tabulated F value. Tabulated F value. Tabulated F value, and here the calculated F value. Now here the calculated F value is 1.1 and tabulated F value is 3.35. You know the conditions. The calculated F value is it is a smaller than lesser. The calculated F value is smaller than tabulated value. Here, this is a calculated F value and this is a tabulated F value. This calculated F value is smaller than this tabulated F value, and the null hypothesis is accepted here. Hence, the difference in the variance. And of the 2 hour samples of not significant, 5% level of significant. This is the problem. Here the finally conclusion is the calculated F value is smaller than tabulated F value. So null hypothesis is accepted. I will stop here only and continue the remaining problems next time.